There's no worksheet or work out of the textbook, but what we're doing is going to engage with square numbers and look for some patterns and try and build up our skills, because there's a few areas in maths where this is really important skill for you to know and understand. So what I'll do at the very end of the video, I'll show you where this kind of work leads on to, but they will be separate videos. I think the length of this video, by the time we work through it, will be long enough. So I've just got a little bit at the end where I'll show you where this kind of activity will lead to next. So if you're a teacher here listening to this, you sort of, these are the kind of things I'd roll into a classroom with and just off the cuff ask a few questions and get this whole workflow driven by the questions and what we see. So it's just taken a while for me to get that into a video format where I can share. So hopefully you find something useful out of these videos. And if you're a student and something just passes you by, something I say or do passes you by, because it's in this format, it's so easy to pause it, rewind it, play it again, and really focusing on what was missing for you. And the final thing I've got to say is that I'm not making a video for you to sit there passively watching. It's one of those things where as you're doing this work, I'm expecting you to have a pen in your hand, looking at something, seeing a new way perhaps of doing some work, and then trying that for yourself. Okay, so we're working on squares or square numbers. Now, just a few things as we start. We want to work on positive integers. And for us, we might say whole numbers. Whole numbers. Okay. Let's just start here and do our work here and keep things simple for a moment. So again, I'm going to create a table in a moment, and those positive integers or whole numbers, I'm just going to use a little bit of algebra here. And I'm going to use lowercase n to represent any of those numbers. And then we're going to square it. So whatever number we use, we're going to square it. And that's where this little symbol up here, this little index up here, it's a 2 that represents a number that's being squared. So let's start off with some really simple cases here. We might have 2 times 2, and that's equal to 4. So 4 is your square number. And I'm going to show you a way in a moment to represent that. So another way, we could write 2 squared using that little 2 there, and that would be equal to 4 as well. So you'll see all this notation throughout the video and different ways of working. So what we need to, next thing I need to tell you about is the area model. We're going to use this because it's a visual way to do a lot of the multiplication we need to do. So what we have, often what we have are rectangles. Now we use little ticks like this to represent these things. These lengths are different, so the opposite sides are the same, but their lengths are different from the opposite side. So we might just say area equals length multiplied by width. Now, of course, a square is a special version of a rectangle. where all the sides are the same length. See how I've just used one set of ticks? I'm not sure what they're called, but I call them ticks in here to represent that they're all the same. So let's get started, and I think we can start this without too much number crunching. We can set up a table, and we'll do that now, and we'll use n to represent the integer, and we might write a few of those integers out first, or whole numbers. We'll start with the number 1, and then we'll just make a list. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so why this up to 12? I'm thinking that you might have some knowledge from the times tables here. When we start squaring the numbers, hopefully at this stage you've learnt that any number times by itself is actually a square number. If this is brand new to you, then it's good we're talking about this and you're looking at something that you may have missed. And I understand you could have missed it because these important numbers are buried within the times table. So we're going to square that number, okay? So the index here is 2, so that represents that number multiplied by itself. So I'm not going to do them all like this, but just to reinforce that idea, 1 times 1 is 1. Okay, 2 times 2 is 2. 3 times 3 is 9. And then I'm just going to write them out here. And that's because I know them and work with them and understand what's going on. But hopefully when you're doing this, you've got the pen in your hand, you're doing this following along, you're thinking about 10 times 10 is 100. 11 times 11, or 11 squared, is 121. And 12 times 12 is 144. So hopefully that's come from the memory banks. Okay, you've spent a lot of time learning your times tables, and you're seeing these numbers as square numbers now, which would be a good start. So make that table, and then we might run into a bit of a problem here because we're going to extend that table out, and I've run out of room on the board. So the next number that I want to deal with is 13. And you might not know that when we square that number, that's 169. Okay, so there's ways that we can work this out. We can go 13 times 13 and do it this way. 9 times 9, 3 times 3 is 9. 1 times 3 is 3. Put the 0 down here, multiplying all this by 1 now. Add them together, we've got 169. But what I want to show you here is using this area model. I think this is probably the best way to do this because it's visual. I'm thinking I've got a square because what I'm chasing is this number down here, the square of 13. So, but the difference here is I'm thinking about 13 as 10 plus 3 is equal to 13. So, and I'm going to draw a line down here, and this little bit in here is the 3. Okay, I'm going to do the same down here. This is 10 and a 3, and what I've done here is, it's not quite to scale, but I've created 2 squares. This is 10 times 10, or 10 squared, or 100. Okay, I haven't got much room down here, but this length here is 3, and this is 3, so 3 times 3 is 9. And that information, by the way, could have come from this table here. If this is brand new to you, and you're learning this for the first time, having this table in front of you is really important. So the next thing we need to work out is we've got these, they're not squares, they're rectangles. So we just need to be careful here. I might change the color. And this is 3 times 10. This length here is 10. So that's 30. And fortunately, they're both, as you can see here, if this is 10 from this length here, down here, and this is 3, this is 30 as well. So we've got a little bit of addition to do here. We've got 100 plus 2 lots of 30 plus 9, and that's all equal to 169. So that's the technique, and I think at this stage it would be good to pause the video, and I'm wondering if you can move now from 13 squared to 14 squared up to maybe 20 squared using this technique, and you go ahead and do that. I'll stop and clean the board and we'll talk some more. Okay, so I've cleaned the board. I think you saw me, I've fast forwarded through working all these numbers out myself, so I've just done the same work that I've been asking you to do. And I want to stop now and I want to show you, maybe you picked up on a different method for some of these. I think it's worth talking about. 16 and 18. I might do those ones quickly a different way. So what did we say? N equals 14. I'm looking at 14 as equal to 7 plus 7. So I'm creating some squares here, and there's 4 squares. They're all the same. So 7 times 7 from our table up here is 49. So I've got 4 squares of 49 in here, and I'm going to add these up. I'm just going to do a bit of mental arithmetic here. I'm going to say 4 times 50, subtract 4, and that should take me to 200. Take 4, and that will leave me with 196. So tick, that's right. So that's another way to do that. 16, I'm thinking about 16 as 8 plus 8, and again here I've got, if these are 8, these are going to be 64 in each of these boxes here. So just quickly I'm going to do this as 4 times 60 plus 4 times 4, so that will be equal to what? 240 plus 16 equals 256. Okay, and then finally I'm looking at 18, and looking at 18 is 9 plus 9, and the same thing's going to happen here. These are all 81 in here, and I'm going to do this as 4 times 80 plus 4 times 1. So that's 320 plus, 4 times 1, which is 4. So that's equal to 324. Now I'm just going to use the information that we've got in front of us here, and I've asked you to look for a pattern and look for the distance between each square number. And hopefully you're seeing this kind of pattern here where the distance between each square number is an odd number, but they're consecutive odd numbers. So I might pay to draw this out on a bit of a number line here just to get us started. Here's 0, there's 1, we've got 4, and the distance there is add 3. And our next square number is 9, and the distance between 4 and 9 is add 5, and we've got 16 here, we've got plus 7. Okay, so that all checks out. 16 minus 9 is 7, and I suspect this pattern keeps continuing on. So we'll test that out in a minute, but we've got to try and understand. What we want to do is try and understand where this pattern comes from, and we might start with something like, let's start here. Here's a convenient number. We've got 100. Okay, so this is 10 by 10, and this is 100 in here. And the next number we want to build is 121. So how do we do it? What's the distance between these two numbers? Nice and convenient. Let's add 21. So we've got 21 little blocks to play with, if you like. If I line 10 of them up here, that's 10 of them, and I line the other 10 up there, I've got 1 left to play with, and I need to put that in the corner to create the next square. So the dimensions of this new square here are 10 plus 1, which is equal to 11. And that gives us our new square. And that's really important. And what we need to think about now is some sort of rule that we can apply. For example, I've got 13 squared here, and I want to know how many blocks that I need to create 14 squared, for example. All right. So the one way I can do it, I can keep following this pattern along here. Plus 23 plus 25 plus 27, and work it out that way. That's fine. But for instance, there's got to be a faster way to do this, and we need a bit of algebra here. What I'm thinking about is this. If I've got this block here and the sides are some number, and what we do is we add 1 row of that same number there, and then we add 1 row of this same number there. So in effect we have 2 rows, so let's call that 2n, plus we always need 1 in the corner. So our new rule is 2n plus 1. So if all I knew, let's test this out, if all I knew n was equal to 13, and I applied this rule that we've just worked out, 2 times 13 plus 1, now that's equal to 26 plus 1, which is equal to 27, which was a number we worked out up above. So what's happening here is something really important, some useful rule that we can apply in a lot of settings to help us out. So there's an important teaching moment for you, and we need to check now if this pattern holds, and I think you'll find it very useful. We're at the final stage of this video, and I want to perhaps go into some new territory. So I'm looking at some numbers here to start us off with, and we might start with a square of 30. So we've got a question here, what's the distance between the square numbers? We've done a lot of work to help us out to start that off, but let's just play a little game here where we've got 30 squared. That's where we're going to start, and that's equal to 900. We're going to start here, and this is the same thing as 30 squared, and we need to move to the next number, which is going to be 31 squared, and then say 32 squared. And like let's just put ... because we know that's going to continue on. We could start at another number if we like, but we want to treat this game like, let's pretend that the ground there is lava and we don't want to step in it, and so we need to be able to know what the next square we're going to land on, and we need to know exactly how many steps or how big the jump needs to be to get to the next square. Okay, so there's a couple of things we don't know. We need to work these things out, and here's a good little test, like the floor is lava type thing. We need to check that it's right. So let's explore a couple of the rules that we've got. So, and a couple of different ways that we can work. We know we can build the next square this way. We know we can add these little bits on here as if they were tiles that we're playing with in primary school or something, and we're building squares with them, or there could be concrete pavers or something. So to build the next square, which is 31, I'm going to need 30 and 30 here and 1 in the corner. So I know up here I need to add 61. Okay, so 900 plus 61, the mathematics there is quite easy. And if we knew the patterns, we know if this is plus 61, then we suspect here we need to add 63. So this number over here, the square of 32 should be 961 plus 63. So let's just quickly do the maths there. Carry the 1, 1024 is our number there, and we needed to jump 63 to reach that one. And so we can keep playing this game, but it's important. What I'd like to see here, as you're playing this game, you might be doing it by yourself, you might be working in pairs or threes, and so there's enough work where guys can check what they're doing, and maybe the steps we can revisit and go back to some of the previous skills that we taught. 30 times 30, and that's 1 and 1. So that's 900 plus 30 plus 30 plus 1. So that's equal to 961. So that's correct. And we could use our formula here, 2n plus 1, to predict how many squares we needed to 2 times 31 plus 1, that's 62 plus 1, so the next jump is 63. So that's all working out, and we're double checking our mathematics here, which I think is a really important skill to have, and we're using a different method to check what those numbers should be. So that's 900 again. 2 times 30 is 60, that's got to be 60 as well, and 2 times 2 is another square, 4. So if we add these up, we get 900 plus 124, so that's equal to 1024. In the introduction, I talked about having a final little segment just to show you where we're going next. Now I'm going to talk quickly here because I think I'll make these the subjects of other videos. But I think it's an important question. I'm getting you to learn these skills, and I did say they're used in mathematics all the time. So I just chose 24 squared, and that's equal to 576. And I've shown you a way to work that out. If we connect things up here, we're sort of almost algebra in a way, because I've asked you to think about this as 20 plus 4 and then squared it. So and how this works out is that we what are we doing? We're squaring the first number, then we're adding 2 times these two numbers here, so 20 times 4, and then we're squaring the last number, which was 4 squared. Now in algebra that looks like a plus b squared, and then when we expand the brackets there, we get a squared plus 2ab plus b squared. So there's one aspect of what we can do. Other things, we were talking about squares. We started off with everything being the same length. Now what happens if, say, this side is 24 and this side is 26? Well, we can start to think about this in the same sort of way, same sort of method. We could have 20 plus 6 multiplied by 20 plus 4, and we could work that stuff out. So there'll be less squares involved, but again, that's a second thing, a second direction that you can take this. Also, while we're dealing with squares, I think there's an important link here to teaching about the square root. Okay, we don't write a little 2 in there, and so we need to spend some time and explain and use this style of work and this knowledge here to understand that they cancel, and the square root of, say, 100 is equal to 10, which we'll explain this in another video. But when I think about the square root, I'm thinking about the one-dimensional length that describes that square. So there's some really interesting work there, and for numbers in particular, let's do this. What have we got? Let's put 8 squared here. That's 64, and let's do 9 squared is 81. So for example, I might pick a number in here, 70, and I want to know the square root of 70, and I can use my knowledge of what I've just learnt, 2n plus 1. 2 times 8 is 16 plus 1, 17. So I know the square root of, I know 70 is between these two squares, and I can roughly think about the square root of 70 as 8. I should change this to approximate. 8 and 17 on the denominator, which come from this number, and then I think about the distance from 64 to 70, and that's 6 on 17. So there's another skill that we can build on. So the final thing, I think, where it's really useful to be working just on squares is when we eventually introduce Pythagoras to students. Now, we often go in cold to this topic, and the struggle for students is real. There's things in here they don't understand. The square, and also the square root sign. Okay, I'm just going to use maybe a Pythagorean triple here to just demonstrate what we're talking about here. So I think it's really useful. Probably the most useful thing to work with students is understanding the sum of the squares, and through this little talk we'll probably end up proving Pythagoras, just to illustrate this point, just how powerful this is. So if we label this as these sides here, and that's equal to 5, we know this is true. Let's just demonstrate it using the formula a squared plus b squared. And so what we're saying here is 3 squared plus 4 squared. And what's that equal to? It's got to be equal to 5 squared. And let's check this out. 5 squared is 25. 3 squared is 9 plus 16, and that actually remains true. What's really useful is all this play with the squares, and particularly the building of the squares. Now, if I had 3 squared, which is 9, adding the 4 squared, 4 by 4, which is 16, what's really useful in all this work that we've been doing is to prove Pythagoras. All we need to do is really rearrange those 9 squares. We're going to put 4 of them on the end here and 4 on the end here, and we've got 1 left over. We've got 9 to play with, and so that has just built 5 squared, which is equal to 25. So that's why, if you really want to know, that's why I set this work up and do it this way, because I see a lot of times students going into cold into this thing, struggling with it, not understanding how to manipulate the squares. And it's really amazing that when we work on the triples, and I might have to make a video on this, so much of mathematics is that we're only solving something for one unknown, and with this type of work and understanding of squares and how it works, we can set up questions where students are actually solving for 2 unknowns, which is pretty amazing thing to think about and get students to do. So I hope this video has been helpful for you. I hope that you can see why it's worthwhile and where it goes to next. So thank you.